So, in fluid mechanics, there is a topic which is Pascal's law. So, first of all, what did we understand from Pascal's law? Actually, the Pascal's law states that in a static fluid, the pressure, or we can say that the intensity of a pressure at a point is the same in all the directions. So, the point is how can we derivate it? How can we find it? So let's prove this Pascal's law. For proof that Pascal law, we need a wedge-shaped free body. Wedge-shaped free body. So let's consider a wedge-shaped free body A, B, C. In that body, Px, pressure Py, and pressure Ps comes along at perpendicular base and hypotenuse. So, what are the force acting on that body at that time is sigma fx, which is we know pressure is equals to force by area. So, what is the force at that moment is pressure into area. So, the pressure at that side at force at AB is pressure Px multiplied by area. Area is distance into width. Let's consider distance is delta y. So delta y and width is 1. Width is about a unit mass, unit area. Now the pressure exerted on AC direction, AC part, it's Py multiplied by area, and area of that part is delta x and width is 1. Now at that part we say the force exerted is Ps multiplied by area, and the area of that part is that Ps distance delta s into width is 1. So they are the force acting on that body. Now what is the weight of that fluid element? Weight of that fluid element is W. We know specific weight of any fluid is weight of the fluid by volume of the fluid. By that formula, by that property of the fluid, we get is weight of the fluid is equals to specific weight of the fluid into volume of the fluid. Now volume of that fluid, as you can see that this body is a wedge shaped body. So generally the wedge is a prism type of shaped, and the prism type of shaped formula, volume formula is width into height into half into gravity. Width into height into gravity, which is W. Sorry, gravity is not the part of that thing. So small w, which is specific weight, and width of the that part is is delta sx delta x, and height is delta y, and where is half is half. After multiply all of them, we get Sx delta x and delta y by 2. That was the weight of that fluid element. After all of that, now we have every required things for derivate our Pascal's law. Now for for equilibrium, delta fx and delta fy should be equal to 0. Now at that hypotenuse of that triangle, you can see we divide it in that way, force PS, and these two parts perpendicular to here and here, the force exerted on that part, the pressure exerted on that part is PS cos theta, and at that part is PS sin theta. So what did we understand from that part? Pressure exerted on that part is equals to the pressure exerted from that part. Px Px minus, this is on the other side, that's why we take it in negative, Ps sin theta equals to 0. If they are in equilibrium, then they are equals to 0. Px minus Ps sin theta. Now where is Px? Is Px delta y into 1 with 1 with subtracted from Ps sin theta. Ps sin theta equals to 0. For simplify that part, let's take minus Ps sin theta on the other side. Px delta y with 1 equals to Ps sin theta. Now we know Ps is Ps dot delta s into with 1 and sin theta equals to Px delta y 1. Let's multiply them, which is Px delta y equals to Ps delta s and sin theta. For the next part, let open the pantries. Open pantries. We know sin theta is perpendicular by hypotenuse. So in our wedge type of fluid element, perpendicular is Sy and the hypotenuse is delta S. Delta y equals to Ps delta S equals to delta y by delta S. So let's cancelize that part. Delta S cancelled by delta S and delta y cancel out by delta y. So what we get from that part, sorry, Px equals to Ps. This is our first thing for prove the Pascal's law. Similarly, delta Fy delta Fy is and delta Ps cos theta is equals to 0 if they are in equilibrium. Let us start proving that delta Fi, which is Py, Py, Py subtracted from Ps cos theta, if they are in equilibrium, so they are 0. From here, we know Py is Py delta x with width 1 minus Ps cos theta. Now take minus Ps cos theta on the other side for simplify further. Py delta x into 1 equals to Ps cos theta, where is Ps cos theta. We know the value of Ps, which is Py delta x. Let's multiply that part here, which is delta x equals to Ps is Ps dot multiply by delta s into 1 and cos theta. We know very well the value of cos theta also, which is based by hypotenuse. Delta x equals to Ps and delta s, we multiply that part which from where we get delta s, and the cos theta is based by hypotenuse. So in our vest like fluid element, the base is delta x and the hypotenuse is delta s. Delta x by delta s. Now cancelize that part, we get Py equals to Ps. This is our second important part we get. Now by first and second, Px equals to Py equals to Ps. All pressure are equal on that wedge shaped fluid element. That's what we need, as theta is an arbitrary angle. Pressure is same in all the directions at a point in a static fluid.